Welcome to Cosmic Concepts, where we break down complex theoretical physics into understandable ideas. I'm Dr. Alex Morgan, and today we're exploring a fascinating theoretical framework called UIGC, the Unstructured Information to Geometric Consistency Theory. Imagine the universe not beginning with a bang, but with information organizing itself. That's the core idea behind UIGC. Instead of assuming space and time existed from the start, this theory suggests something more fundamental came first: pure information, existing as potential relationships without any structure. Think about it this way. Before there was any where or when, there was only the potential for connections and relationships, raw, unstructured information. The UIGC framework proposes that our universe began when this information started organizing itself into consistent patterns, and these patterns became what we experience as spacetime geometry. This is quite different from the traditional Big Bang model. Instead of a singular point of infinite density exploding outward, UIGC describes a phase transition, similar to how water freezes into ice. Information freezes into geometry, creating space, time, and physical reality as we know it. What's particularly elegant about this approach is how it addresses several persistent problems in theoretical physics. First, it's truly background independent, meaning space and time aren't assumed to exist beforehand, but emerge naturally from information organizing itself. Second, it resolves the problem of singularities. In traditional models, black holes and the Big Bang contain points of infinite density where our mathematics breaks down. In UIGC, these aren't singularities, but regions where informational coherence is reorganizing itself, a much more mathematically tractable situation. Third, and perhaps most importantly, UIGC offers a pathway to unify quantum mechanics and general relativity, the two pillars of modern physics that have stubbornly resisted integration. It suggests both quantum uncertainty and gravitational curvature arise from the same underlying informational constraints. Let me explain this last point. In quantum mechanics, we can't simultaneously know everything about a particle, like both its position and momentum. In general relativity, gravity manifests as the curvature of spacetime. UIGC proposes these aren't separate phenomena, but different expressions of how information organizes itself into consistent geometric patterns. The theory also provides natural explanations for other puzzling aspects of our universe. Why does time only move forward? UIGC suggests this emerges from information becoming increasingly globally consistent. The expansion of the universe? That's another expression of this same organizing principle. Even the number of dimensions we experience, 3 of space and 1 of time, isn't arbitrary in this framework. UIGC proposes 4 dimensions represent the minimal conditions needed for stable geometric consistency, similar to findings in other advanced theoretical approaches like tensor networks. What makes UIGC particularly compelling is how it aligns with other cutting-edge theories like holographic principles, causal set theory, and loop quantum gravity. It doesn't contradict these approaches, but provides a unifying interpretive framework for understanding them. To summarize this profound shift in perspective, UIGC suggests the universe isn't built in geometry, but as geometry. Space and time aren't the stage upon which physics plays out. They're more like the choreography that emerges when information achieves internal consistency. The implications are profound. If UIGC proves correct, everything from the Big Bang to quantum discreteness to gravitational curvature are all expressions of one fundamental principle: unstructured information organizing itself into coherent patterns. It's an elegant vision of cosmic origins that reframes our understanding of reality itself. This has been Dr. Alex Morgan for Cosmic Concepts. If you enjoyed this exploration of the UIGC theory, please subscribe and join us next week when we'll explore quantum field theory and what it means to say particles are excitations in fields. Until then, keep looking at the universe with wonder and curiosity.